Good morning, sir.
Good morning. Very good morning.
Good morning, sir.
Good morning, sir.
Suprabhat.
Good morning, sir.
Good morning.
GM
Good
sir.
morning, sir.
You put my response in that loop.
Good morning, sir.
It will continue
Good morning, sir.
with that. Thank you. Same to you.
सर वो क्लास में होता है ना ऑनलाइन ऑफलाइन क्लासेस में
So it's showing only 120 participants. Anyway, do you find any file shared there?
Blank page, sir.
Blank. Fantastic.
Yes.
Now,
Sir, you received everyone's mail, sir.
I am still continuing with that checking that whether I have received everybody or not.
Okay,
There
sir.
are so many multiple files, multiple mails. Now, do you find anything on screen?
Yes, sir. Yes, sir. Yes, sir. What diagram?
What
diagram?
What is that diagram?
The crane like
GD is an string which supports the load F.
W.
To support the load W,
Hmm.
which is hanging from a location F, which is at the end of a horizontal bar CF, and we need to put it in this position. Of course, we need some arrangement of supporting this. Okay. So one thing, have you seen that electric post there, roadside? There you'll find this vertical member and supported by one inclined wire-like thing.
Yes, sir.
One end
Yes,
fixed at the ground, other end tying up at the top of that electric pole in that way.
Yes, sir.
And something here, some connection, maybe it is a hinge connection or pin connection. It is there, CF. But if you provide a weight there, W, naturally it will automatically rotate and it will come down. It will fall like this and it will become vertical. So to hold it in its position, this member BE is provided. One end B is connected with this post, other end E is connected with this horizontal member CF, right?
Yes, sir. Yes, sir.
So this weight is supported by this system or these connected members. Out of that, AD, CF and BE, these are metallic rod or wooden bars like thing, and it may be a flexible either metallic rope or string. It is provided there, so that if it is not there, the whole system will rotate with the effect of this load W here about the point A, and it will collapse by rotating towards right in this clockwise direction. So to restrict it from its falling, this support rope is provided. Now, what are the forces developed or generated, or how the force W or this total weight W is transmitted to other parts? Definitely here will be some tension developed at G on
Yes,
this
sir.
rope GD.
Hmm.
There will be a support reaction at A. There may be two components, one vertical, another horizontal component, or any other direction according to your convenience. You can do that thing, but ultimately a gross reaction force will be developed there at A. And intermittently, these members are helping to pass this force, to transmit this force to the ground at G and at A through this member CF, member EB or BE, and this vertical post AD. Now let us see the next diagram. Get the point. If we remove the support at A and remove the rope at D, that inclined rope GD, then what we'll find? You have to replace those supports with proper reactions. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
So this is the combined reaction which have two components at A. Now the book or diagram I have copied, it is giving some notation AX, AY to indicate the support reactions, but normally I do not prefer, and I also advise you not to follow these notations. You write R, capital R, to represent in short the reaction. So it may be RA, R capital A with subscript X, so that X is the horizontal component. It is represented by that RAX and it is RAY. And at one corner or so at some suitable location, you should indicate that with this right angle notation, towards right it is X direction, towards vertical upward direction it is the Y direction. Anyway, those formality you know it. Now these are the reaction components along horizontal and along vertical direction. Now here for the flexible rope, here is the tension developed indicated by T, and the other members we are considering them as a whole, a single thing. Here is the applied load W. Done. Next, if we consider individual members like B, E, C, F and AD, then they will come gradually like this. Originally it was the vertical post AD. Yes.
Sir,
Yeah.
why AX is coming here?
Why AX is coming here? AX
Who
is
is
coming
supply-
here in this way. Now, can you say that AX will not be there and why it will not be there? If it is not there, it will come after calculation, it will come as 0. No problem. It's as simple as that. But from your common sense, if we consider the overall thing and we consider only this weight W and the reaction developed in the form of tension in the member DG. OK, now if we take no AX, then what about the sigma fx? W cannot have any X component. But what about T?
It can have, sir.
T can have. So towards left, it will be T multiplied by cosine sine of this angle or cosine of this angle made by the direction T with the horizontal. So to balance that thing, you definitely need this. Now, one more thing. Even if we do not consider AX, then when you frame that equation of equilibrium sigma fx0, sigma fy0, there automatically you will get those things. That if there is no AX, naturally horizontal component of T for one force and on the right hand side that is equal to 0. So sigma fx is equal to 0 will mean T cosine theta is equal to 0. So what about the tension here? There is no tension, but it is not possible practically. So when you are considering this framework and you are applying some weight here and there is no force applied, so it will automatically rotate about the point A and it will collapse in this direction, in this clockwise orientation. So it will fall on this side. So to support it, to protect it from falling, we need to apply some force in terms of this rope GD. And when it is there, definitely it will provide some horizontal component and it will act a very important role in that expression equilibrium equation sigma fx is equal to 0. Algebraic summation of component of all forces along x direction is equal to 0 and automatically it will come. So logically that also you can build it up. You may consider x is not there, but in that case T will also be 0. And if T is 0, so this unbalanced force will give you only force equilibrium in vertical direction. But what about the moment equilibrium? moment about any suitable location, it must give you 0. Sigma ma is equal to 0. So W multiplied by this distance, that is equal to 0. This distance is not 0. So W is 0. But it is the fallacy. You are applying some force and your calculation showing there is no force. Okay. Now, this is the free body diagram of the vertical post AD.
Sir.
Support. Yeah.
Sir, their rope supplies the tension. Then, sir, which part of this diagram supply AX? May we say from starting of the calculation that this part showing supplying AX?
बेटा सोच ले, सुन एक मिनट बेटा सुन, ये आप है, आप खड़ा है ग्राउंड पर, ठीक है, ये आपका हाथ है, ठीक है, समझ रहे हो ना, रिस्पॉन्स करते जाओ.
यस सर.
ये आप खड़ा हो, ये आपका फुट है, दोनों पैर इधर है, ये आपका हाथ है, ठीक है, इट्स योर हैंड, यू आर होल्डिंग सम वेट एंड on that pen or something like that, or in that hook, I am supplying some masses like 10 kg, 20 kg, 30 kg, 40 kg. And what about your self weight, beta? आप कितने वजन का हो?
So around 55.
Around 55. So I put suppose 55 kg, then 60 kg, 70 kg, 75 kg. What will happen to your system of this framework of your 206 members? Bones? Will you feel only pain at your shoulder only or at your wrist? Will not you feel the pain at your foot?
Yes, sir, feel.
That is the reaction provided by the ground. You are not floating in the air. So if it was in that case that you are floating in the air only, this kind of thing could happen. But for equilibrium, as you are not falling down, so this is the only location where some reaction may be provided, and that is through the ground. And your ankles, your toe, those parts will also feel pain, because this weight is ultimately transferred from this wrist, hand to your shoulder, through your that backbone to your legs, ultimately your toes. Now, beta, एक चीज सोच ले. You are flat-footed, resting on the ground, standing on the ground. Now, instead of that, you just place 5 or 6 vertical nails there, sharp end upward, और आप पैर रख लीजिए nails के ऊपर. अभी क्या होगा जब वजन बड़ा हो गया? Nails शुरू में इतना flat है कि आप इसके ऊपर खड़ा हो सकते हो. You can stand barefooted on those nails. But as maybe your 55 kg equivalent weight is 550 Newton or something like that, it is not that much dangerous that the nails are piercing your toe bottom. Okay. Now, if we increase the load on you, suppose you are holding some box on your head and I am providing 10 kg, 20 kg, 50 kg additional masses. So ultimately what happens at this location where there is some vertical nails, sharp ends upward? Initially your 55 kg are quite comfortable that you can stand on that, but when I increase this force, then what happens? Ultimately these nails will provide much force and it will pierce through the skin at your toe and you will get some injury. That is due to the transmission of this force to the ground. So whenever there is some support, the action forces or applied forces must be transmitted through this system to this location of the support. Okay, so this is the free body diagram of the overall system. Applied force, these are the connected member system. Support at A, support at D. At D, the tension developed in the rope. At A, there will be some reaction. Reaction may be the combined reaction. Now, if we do not know AX and AY, at least one thing we can do. It is a 3-force system, applied force W, tension T applied at D, developed at D, and here is some reaction. Now, condition of equilibrium of 3 forces in a plane. Extend these 2 lines of action, W vertical upward, extend this line GD inclined upward, you get a point of intersection. So primary condition of equilibrium is that the third force, which is in the form of reaction at A, it must pass through that point of intersection between the other two forces, that is W extended upward and this T extended inclined upward. This is the point of intersection. So join this point of intersection of T and W, lines extended, with this A. So this will be the line of action of the reaction, that is the combined reaction. So that force triangle will give you that idea that there is a reaction here in this form. So what about its horizontal and vertical component? Horizontal component will be towards right, vertical component will be vertical upward. So X component horizontal towards right and Y component vertical upward. Okay, you can try this thing. Extend this line. You take a simple graph paper. From school days, you have many things stored in your house. Okay, so extend this line vertical, extend this line inclined upward, point. You look at this point of intersection, then join this point with this location A and extend this line. That will be the line of action of the resultant. And when you draw the vector triangle, you will find the T inclined downward, then W vertical downward, then third side of this triangle should be directed from this location to this location so that it is forming a closed vector polygon, that is a triangle for equilibrium. Okay, is there any further confusion?
No, sir.
Okay.
No, sir.
Next thing, individual members. At C, there is a connection. Some combined reaction will be there. We can resolve it in horizontal vertical component. At B, there is one inclined member support. BD, I think, for the BE. So for BE, there will be one reaction at the pin B. We can resolve it in X and Y direction, or directly we can consider the force is transmitted along this line. So it is there in this form of combined reaction. There.
Yes, sir. Here my doubt is there, sir. Why it is inclined in this direction only at B? Like if we resolve it in X and Y direction, would it not be possible that it may be in other direction as specified here?
If we consider the member itself BE, these locations are pinned. So for this pin connection, the rotation is allowed. If we remove this pin at B, so BE will simply swing like a pendulum. Similarly, if we remove the pin from E and release it, maybe we are not considering the self weight here for overall equilibrium, etc. Now, if we do not consider any pin support here, it will simply swing in this way. So reactions will be only linear, not moment reactions. So in that way, the force transmission will be from this location to this location, directly along the member.
Sir, but it should be upward, sir.
Anything. Initially, we do not know what is the actual direction.
Just we are assuming, sir.
Initially, we do not know the actual direction. We assume something. After calculation, if we find anything negative value, so it will be automatically opposite to the whatever we have assumed initially to start solving. Then for the member B, it is the force applied by the member B on the member AD. Then consider this horizontal member CF and this inclined member BE. Now at joint B, everything is under equilibrium, so this pin is also under equilibrium. So this is the force applied by the inclined member BE at that pin on the member AD, and this is the force for equilibrium of the same value, equal and opposite to this value. It was inclined downward, it will be inclined upward. So the force offered by this vertical member AD through this pin B on the member BE. So on the member AD, the force applied at B was inclined downward, and the equal and opposite force will be here when we consider the member BE. This force and this force are equal and opposite. So this is one situation, the force applied by the inclined member on the vertical post, and here force developed or generated on the inclined member BE at that particular joint. So overall equilibrium for the whole structure, the part equilibrium for individual member, etc. You have to consider very carefully. And if you are not sure about the exact direction, nothing to bother about that. You simply go on framing the equations of equilibrium. And ultimately, after calculation, if you get anything giving negative result, it will be, of course, calculation must be correct. Then it is opposite to the assumed direction. Okay. And one thing, suppose when we apply this force, the tendency of that member or this support post will be to stretch this member BE to increase its length or to compress it to decrease its length. What is the natural tendency?
Compressive.
Compressor.
Compressive. And this is the compressive force developed on the member BE. So this is the force at the pin on the member BE. Equal and opposite force will be there for equilibrium opposite to that. So force offered by the member BE on the member AD at the joint B is like that, and force offered by the member AD at the joint B on the member B will be equal and opposite, that is inclined upward. Next, the horizontal force. This force at E in this direction for the member inclined downward. So the same force will be here for equilibrium. Resultant force is 0. So these two forces are equal and opposite. This force at B and this force at B, they are equal and opposite. And for equilibrium, for sigma fx0, this force has definitely some horizontal component. To balance that thing, we need one more horizontal component, that is the horizontal reaction component at joint C. That's why it is here at C, vertical as well as horizontal. Clear?
Yes, sir.
This is the overall framework. These joints are not welded joints. These are pin joints where rotation is allowed. Now, if there was some welding, the vertical post is welded at the ground with some metallic heavy plate, then definitely you need not require this support member. Another welded hand like this, the member CF, it is welded at C. But it is like your shoulder, there is a shoulder joint, and when we apply some force here, your shoulder will allow this rotation so that your hand is not remaining in its horizontal stretch condition, it is coming down. This is the overall free body diagram with the applied force W, support reaction at A, the tension developed due to that inclined member or that string or that metallic wire in the form of this tension T. Then this is for the single vertical post. At B and C, the forces offered by the support members or the connected members CF and BE. These are the individual members CF and BE. That's all. And from this diagram, this is not a concurrent force system as usual. It has got 3 unknowns, and for non-concurrent coplanar force system, you can develop 3 equations of equilibrium, 2 force equilibrium equation and 1 moment equilibrium equation. So solve it. So T, RAX and RAY, or in some book you will find the notation RAH and RAV representing reaction at A horizontal component, reaction at B, reaction at A vertical component. So whether it is RAX, RAY or it is RAH, RAV, doesn't matter. You should understand whatever notation you have used and you have to follow accordingly and nothing to get confused. So after getting the overall equilibrium, sort out these reactions at A, at D. Now what about the overall reaction at A and its direction? It will be magnitude square, summation of the magnitude square under square root. So square root of Rax square plus Ray square, that is the magnitude. And what about the inclination of this overall reaction, resultant reaction? It will be tan inverse Ray divided by Rax. Okay. So then we go for this. T is known, Rax known, Ray known. We find out these forces. Next thing, sigma fx0, sigma fy0 will give you two unknowns, but not directly. But for the third one, you need to do one thing. We take a moment equation about this point. Or one thing you can do, you can directly select the point C. So sigma mc is equal to 0 will eliminate this force and this force directly because distances are 0. So only this unknown force remains. So this unknown force multiplied by this perpendicular distance, it is clockwise. T multiplied by this perpendicular distance anti-clockwise. Ray does not contribute there in that equation MC. And only thing Rax multiplied by this distance from C to A anti-clockwise. So clockwise, anti-clockwise and anti-clockwise. So from that equation, this is the only one unknown. And you can solve it. Once it is solved, you can go for sigma fx0, sigma fy0, and this is the known. So put that value there, and from two independent homogeneous equations, you can find out the horizontal component developed at the pin C and the vertical component of reaction developed at pin C. Okay. Next thing, you can solve for this member, you can solve for this member. That's all. So once you solve for this force, you do not need to find out this force again, because this is for primary condition of equilibrium. It will be definitely same, equal and opposite. And at this point, my advice will be you go through any book and many book. Go through the solved examples first. Nothing to solve those problems with closing the books. You go through the solution, the steps of solution. Of course, you can check the calculation whether they have done it properly or not, but that is secondary. First of all, you go through many solutions through many books. In your class teacher can discuss about only one or two problems in detail. How many times you ask, I will try to answer it within the ability of mine. But thing is that until and unless you provide your capital, your business will not be profitable and you will not get good return. So there is no limit of studying. There is no time limit. There is the only thing you must understand that in this course, if you do not have any passion about any subject, you have to do it. If you feel like that you have gone to some hotel, there is a long menu card, but no food item is of your in your favorite list, or anyway, you do not prefer all these things, but you are hungry. You need to take some food and you have to take it. So if you think that there is no such subject of your passion, you started from learning music, instrumental or vocal, or you are a very good painter. So मैंने तो पिकासो बनना चाहिए था मुझे, और कहाँ मम्मी पापा ने धकेल दिया यूनाइटेड दुर्गापुर में. तो ठीक है, चलो 4 साल के बाद खाने का जुगाड़ तो आप करोगे ना, मम्मी पापा कब तक खिलाते रहेंगे. सो फॉर दैट यू नीड दिस थिंग. खाना पसंद हो ना पसंद हो, एटलीस्ट 8.5 क्रेडिट यू हैव टू स्कोर. अगर आप पूछो सर सबने 8.5 हो गया तो मेरा क्या होगा, एम आई गोइंग टू द टॉपर? बेटा ऐसा नहीं. ये क्लास में टॉपर होना और जिंदगी में कुछ करते रहना दो चीज आर डिफरेंट. So perhaps the person who rather entertained me with that song, Give Me Some Sunlight. Okay, this is something like that. बेटा काबिल बनो, उसके बाद आप जानते हो क्या है. ठीक है. So please
Yes.
Complement or supplement all these discussions there through any book or many book. Next thing, here is one. I think it is a little simpler. two supports are there. At A, it is a hinge support. At B, it's a roller support. It's not exactly roller. It is some kind of rocker. But thing is that it can translate. It can slide along a horizontal direction. But at A, that horizontal movement is locked. But rotation can be there. So the rotational resistance or that moment resistance is not there, but reactions will be there. But when the force is only single vertical downward force, there will be only vertical upward reactions at A and at B. But if this AD, the lengths AD and BD were same, it is symmetric, then the reactions from our common sense, we can say that RA and RB, both vertical, will be same, half of P and half of P. But as it is little eccentric, it is more close to the support A. So more contribution will be there corresponding to the reaction at A, and the reaction at B will be little less. Okay. Now what about the free body diagrams? First of all, we must understand about the overall free body diagram. That overall free body diagram will give you sorry, these are some other diagrams. Here, applied force. Here is the force RB. This is the overall reaction RA, but RAX and RAY are not existing separately. Only a single force can be there. Now, if we draw the, if we write down those equations of equilibrium in X direction, then what about the contribution of P in X direction? P multiplied by cosine 90. RB multiplied by cosine 90, that is the horizontal force, horizontal contribution for RB.
Sir,
Yeah.
why there is RAY, sir? Sir,
RAY
RAY should be 0.
RAY, from our common sense, we can say directly that there is no RAY. But if we approach generally, suppose.
So why, sir, it is inclined at some angle theta?
अरे बेटा ऐसा नहीं है. For this particular case, it is not there. But instead of P vertical, if P is inclined, in that case, ये तो आएगा ना, RA inclined.
Okay, sir. Okay.
So,
sir, this thing I couldn't understand. How are you figuring out that one reaction force is inclined and one reaction force is vertical? Sir, how are you figuring out, sir, this thing? RA is inclined and RB is vertical.
RB is vertical in that way that in horizontal direction, there is no resistance or restriction against this horizontal movement. If you pull this location, it is resting on this support. It is not connected. It is not grounded. It is not fixed there. It is simply resting on a horizontal surface. Okay.
Only
so
normal.
Only perpendicular to this surface. Now, if it was this, instead of this horizontal platform, if it was some inclined platform, then that reaction will be only perpendicular to that. Okay. There cannot be any inclined reaction, only perpendicular reaction. But this A, you cannot slide it horizontally, you cannot move it vertically. Here also you can move it vertical upward, but not in vertical downward. So vertical downward movement is restricted. So opposite to that, some vertical upward reaction will be there. So force will be such that P cannot be applied vertical upward. In that case, it will give some collapse that it will start rotating because it leaves this support. It is free to move upward and it is rotating in anti-clockwise direction. And there is the collapse and it is not giving you that support framework. So only vertical reaction will be here. Here horizontal, vertical, both restrictions are there against movement. So for this particular case, directly we can say that there will be only this RAY. We do not consider this thing. We do not need to consider about this thing directly. But every problem will not of that simple and straightforward like. Okay. Now I need to finish one important job. That is, what is that, beta?
Taking attendance.
Attendance. So download attendance list. it is showing downloaded, but I am not going to that download folder right now. So this situation is a very simple one. Now these ends are the connection of two or more number of members, not rigidly. Simply these are pins so that free rotation is allowed and forces are applied at the joints only. No force applied at some intermediate location on the member between the joints. And these members are considered to be weightless. Self-weight is negligible. These are assumptions. Practically or physically, it never happens. Now, next thing, the individual members. Now, is it okay? Can you see both the diagrams? The overall connected members, applied force, it supports, and here is the individual members and individual joints. So for this member AD, at D, 3 members are connected and 1 applied force is there. So at D, P is the on the joint only, on this pin. P is the applied vertical force, and forces offered by the member on the joint will be along these members. So one force along this member DB, other force along the member DA, other force is along the member DC, and this is the vertical applied force. Now if we consider the individual members AD, their equilibrium. So this member AD is subjected to this force equal and opposite to this force. Can you identify the cursor movement here on the screen?
Yes, sir.
So this is the force offered by the member on the joint, and this is the force offered by the joint on this member AD. Clear? Now at joint A, how many members are there? AD and AC. So member AC is applying some force on the member AD at the joint A on the member due to the member AC. So this is the force applied here. This is the force corresponding to horizontal member AD. Now force offered by the joint A on the member AD is this one, and this is the equal and opposite force offered by the member AD on the joint A at the end A for the member AD, right? And there will be one reaction. If we do not know the reaction direction magnitude initially, and that is quite natural, so we give some general inclination, some unknown angle. Okay. So considering that thing, you can find out the individual equilibrium or free body diagram for individual members and individual end of the member joints. Then what about the member DB? DB is subjected to some force. This force is this one. And at B, this force is this one. So force offered by the member DB on the joint B is this one, and force offered by the joint B on the member BD is this one. This horizontal towards right, this horizontal towards left equal and opposite value. Next thing, the reaction RB. Next thing, corresponding to the member BC, force offered by the member BC at the joint B, and force offered by the joint B on the member BC is this one. And this force and this force, the internal forces, they must be equal and opposite for overall equilibrium. So when we consider the overall equilibrium, we have only one applied force and two reactions at A and at B. When we consider the members segregated and find their individual equilibrium, then only from their free body diagram you can identify this. So when we consider only this member BC, it is under equilibrium. So definitely this is the transmission of the force from one location to the other, and it is acting through the member. So draw the free body diagram of individual joints, find the forces developed. the system for every joint is concurrent coplanar force system. This is the point of concurrency for all forces, whether it is a 3-force system or 4-force system, whatever it may be. There should be only 2 unknowns, not more than that. Okay. Now you can solve individually, and starting point should be where there are only 2 number of unknowns. Okay. You get my point? Yes, no, kuch to
Sir,
bol.
Yes, sir.
yes. Sir, here also we can apply the moment equilibrium equation, no? For
But
the
definitely, we know the methods individually. There is graphical method, purely graphical, measure the length, multiply with the scale. There may be some hybrid beta ek meet ruk. So where we are? We can take the moment. That's true. So one thing is the आप लोग सुन रहे हो ना?
Yes, sir.
Yes, sir.
Yes.
It may be purely graphical solution that draw the lines according to their magnitudes. So length must be proportional to the magnitude with a suitable scale. Now there, it should be purely graphical, means you have to measure the resultant length or unknown straight lines. You measure the length and multiply with the scale factor. You get those approximate value, maybe 5-10% due to the error in drawing or measuring the length, etc. might be there. It may be something hybrid. You take the help of the diagram, but lengths and angles need not be purely accurate or according to the scale of the value and its direction. Now there, suppose if there is a triangle, if we simply write down their angles beside those angles formed by 2 members, it is simply like that. You apply the equations from trigonometry or whatever it may be, the sine rule, or in that way, for simple situations. Or it may be purely analytical. That means you draw the free body diagram, write down the equations of equilibrium, and that's all. Okay. Now, out of these 3, whatever you prefer, it may be purely graphical, purely analytical, or something hybrid, that you can do. There is no restriction. So if we consider point A as moment center and take the moment of the all forces, applied force P and the developed reaction at B, then P multiplied by this distance clockwise and RB multiplied by this distance anti-clockwise, that summation will be 0. And there, in that equation, there is only one unknown, that is RB. So get the value of RB in terms of RB is equal to P multiplied by this small distance AD divided by this big distance AB. Done? So that is the thing. So there is no restriction on which method you will apply, but whatever method, it's a purely graphical, purely analytical, or a combination of that, you must be confident about that, and solution steps must be shown properly in detail.
Sir,
Yeah.
sir, explain the free body diagram at point D, sir.
At point D.
Yes, sir.
At D, 3 members and 1 applied forces are there. So when you are applying this force, the force here is transmitted to the support B and support A in the form of the transmission of force through the member AD and through the member DB. So definitely some force is there present through this member AD.
Yes.
Now you just think about that, you remove this member CD. You remove this member CD and 2 separate members AD and BD are connected through a pin at D. This is not a single state member AD. It's 2 member connection. Now what will happen to this?
Sir, D point goes down.
D point goes down. So for that you need some support in the form of this connected member. So
Yes.
when you are providing that support, it is not allowing it to move downward freely. That is, that collapse is restricted. So definitely some force is developed here. So that is the forces for the member AD, for the member BD, and for the member CD. These 3 reaction forces at the joint, and this is the applied force P. Okay.
Okay, sir. Understand.
Now, next thing, you come to this diagram. At A, the reaction RA. At A, just to hold a minute. So at A, 2 members are connected, AC and AD. We are considering that the member AC is under compressive force. The forces are acting inward direction. So it is trying to shorten or compressing it. And for equivalent opposite force at the joint, it is towards the joint. But how do we understand the member will be under compression? What about the member AD? Forces are away, means it is trying to pulling that member or to stretch it, to lengthen it. So the tensile force is indicated in that way. But we do not know whether it will be under tension or under compression, or the member force will be showing such compressive nature or tensile nature. We do not know. So that's why we are considering no direction, or even if we consider any direction, it will be uniform. So for all joint forces, consider either tensile forces or compressive forces. At the end of the calculation, if you find anything negative, so it will be opposite to the actual direction you have considered. So at A, develop reaction RA, other 2 forces along the member AC, along the member AD. Similarly at D also, this is the FAD, this will be FDA, this is P. Now here also we would have draw these dotted lines without showing the direction. It could be like that. Here, if it is compressive, that also you can do, but the only thing, you try to solve it graphically. This is the vertical line upward, and for that one side of the triangle means only 3 forces are there.
We have another class at 10, sir.
Okay, I'll just quickly wrap it up within a minute. Okay, so these are the individual joints. Then for that individual joint, this is the figure, graphical solution. RA, this you do not need to solve it graphically, but this force diagram will give you some help. So RA, other 2 lines are known. These lines should be directed such that they give a closed vector polygon in sequence, that is a vector triangle. So FAC is actually directed in this way. So this force is actually directed in this way. It means the member will be subjected to force in this way, that is the compressive. So for compressive force, the joint force will be towards the joint. And this is the force towards right, FAD. So this is towards right means force acting away from the joint means it is tensile. It is trying to pull that joint. So one is known from this diagram. Then you come to this 4-force system. P is known, FDA is known. Then draw a vertical line and a horizontal line through this point and through this point, get the point of intersection, get this closed vector polygon. Next one, after solving it, once it is known FCA, then FCD and FCA can be determined, or if it is already determined and it is determined, then form that vector triangle to give this. You can find out these angles and utilize those things. You can use the sine rule, you can frame the sigma fx0, sigma fy0, whatever it may be. So individual free body diagrams, etc. So those things are very important. Primarily we discuss in detail, but thing is that in every class I cannot provide that much time. Okay, so please make these screenshots. This is one for all these joints. This is graphical force guideline. Is it done? Then this was the original problem. Next thing was these individual free body diagrams for the member and the overall. Next it was joints without showing the actual directions. Initially we start with that, we do not know. And finally we can go for individual joints, and these are the helping diagrams for graphical solution, and these diagrams directly give us the nature of the forces. Okay, so let me close here. So please do some practice through any book.